Hey everybody, Mr. Quick here. Today we're going to be talking about Eureka Math / Engage New York Math, Module 4, Lesson 16. Write expressions in which letters stand for numbers. So essentially we're going to be given some different expressions, and we're going to have to write them out. So you have to take what is said or what is written in word form and then put that into an expression. So let's go through a couple of examples. First thing, we've got several examples here of what I'm talking about. So each statement could be created. You could use them to create an expression. And so, but the first thing you have to do is be able to know what is important in each sentence. So for these sentences here, all we're going to do is underline the important words for now. Okay, so for A, the sum of twice B and 5. Well, the sum tells me there's going to be addition. Twice tells me there's going to be multiplication. So those are the two key words because those tell us what math we're going to be using. For B, the quotient of C and D. Quotient tells me division. Doesn't look like there's anything else beyond that. For C, A raised to the 5th power and then increased by a product of 5 and C. By the product of 5 and C. So A raised to the 5th power, that tells me we're going to have an exponent. Then increased, showing me that we're going to add by the product, multiplication, of 5 and C. So we have three different types of equations here. Three different operations, I should say. D, the quantity of A plus B divided by 4. Quantity plus and divided. For E, 10 less than the product of 15 and C. Less than shows me subtraction. Product shows me multiplication. And finally for F down here, 5 times D, then increased by 8. 5 times D, again multiplication, increased by 8. We're going to add. So this is one of the first steps when you have a statement that you need to make an expression out of. One of the first steps would be to see what operations are already involved in the question. Let's go ahead and look at one together. Okay, so here we have another statement. The sum of twice B and 5. So keywords we're looking for here, we're looking at sum, so I know there's going to be addition, and twice, which means a multiplication, and it also specifically means we're multiplying by 2. So if we're going to take the sum of twice B and 5, I know that twice B means 2 times B is going to go together. Sum means we're going to add it to 5, so that our new expression becomes 2B plus 5. So now we've written an expression. We haven't written an equation because we can't solve it. There's not an answer to this equation, to this expression. So if it said B was equal to 3, then we would know that B was 3. We could do 2 times 3, which would be 6, plus 5, and then we can solve it. But since we don't have information like that, all we can do is write an expression at this point. Okay, here's another one. A raised to the 5th power and then increased by the product of 5 and C. That sounds like there's a lot there, and there is. But let's take it one at a time. When I see A raised to the 5th power, then increased by the product. So I know we're going to have an exponent. We're going to add, because if you increase, right, if you increase your wallet by $5, you're putting $5 more in your wallet. And we say product, we're going to multiply. So I'm going to just break this apart one piece by one piece. A raised to the 5th power. I know that's going to be A to the power 5. Then increased, which means I'm going to add, by the product of 5 and C. Well, product of 5 and C means multiplication, so 5 times C. So does this make sense? A raised to the 5th power, then increased by the product of 5 and C. It does. What we wrote down in the expression makes sense based on the statement. And so we have A to the power 5 plus 5 times C. That's our new expression. Okay, got a couple of actual examples here, and we're going to see if we can't write out the expression and based on these word problems. Camilla's weight, we're at this top one, Camilla's weight has tripled since her first birthday. If W represents the amount Camilla weighed on her first birthday, write an expression to show how much Camilla weighs now. So first things first, we're going to say, we're going to underline the keywords tripled, right? Since her first birthday. That looks like that's the only mathematical term. Triple means multiplication, but a specific multiplication equation, right? It means times 3. So if something triples, that means you've multiplied it by 3. So one way to think about this, if you're having trouble just writing out what the problem that you think it would be, or the expression you think it should be, actually put a number in there. So let's pretend that Camilla weighed 10 pounds on her first birthday. Well, if it's tripled, that means times 3, so then she would weigh 30 pounds. That's not the answer to our problem. In fact, we definitely don't want to write that down as the answer because it's not true, or at least we don't know if it's true. But what you can say is, well, I know we're taking something times 3, and they're saying that W represents how much she weighed. So instead of 10 pounds, which we don't know if that's the actual weight, we're going to write W times 3, and we know that you don't want to actually write an X multiplication symbol because it looks like the letter X, it looks like another variable. So we'd say just W times 3, and we also know that the number comes first, so we have 3 times W would represent what she weighs now. So 3 times her weight on her first birthday, or W. Okay, let's take this information and let's move down to the second problem. Let's try one more. Nathan brings cupcakes to school and gives them to his 5 best friends, who share them equally. If C represents the number of cupcakes Nathan brings to school, write an expression to show how many cupcakes each of his friends received. Well, key thing here is sharing with his 5 best friends. C is going to be how many cupcakes he has. And then it says, let's see, he shares them equally, so they each get the same amount. If you're sharing, you're dividing something up, right? So I know we're going to have a division in this problem. So let's say that he brought 10 cupcakes, right? Well, if he divided them among 5 friends, they'd each get 2 cupcakes. Well, we don't know if he actually brought 10 cupcakes. All we know is he brought C cupcakes. So we can then replace that C, divide C by 5, you have your new expression. You could also write it as a fraction, C over 5. Okay, that's all the time we have for this video. We're going to do a few more examples in class, and I'll make sure that we have this down. Thanks for watching, and I'll talk to you soon.